Okay, we are back. In this segment, I'm going to go through some of the questions relating to water cycle and anything relating to water. Right. At the same time, if the question comes in as something that is quite simple, okay, I will also go through them. Right. But the tougher process skill like kind of questions, I will leave them to later. Okay, if not, then let's start. Let's look at the first question, something very familiar. Diagram below shows a cylinder and a plunger. Okay, this is P4 on metal. Okay, this is P4 on metal. So the diagram shows a cylinder and a plunger. Ahmad filled the cylinder with water, and then there's some air here. Why is Ahmad able to push the plunger down without air or water escaping? So in short, we are saying that there's nothing wrong with this plunger, but how come he can push it down? Is it because air has weight? Air
can be compressed.
Air can be compressed. Okay, I heard that. Air can be compressed.
Air has no definite volume.
Okay, but interestingly, air can be compressed is not in an option, not any one of the option. So air has no definite shape, air has no definite volume.
Volume.
Right? What does it mean when we say that air can be compressed? So let us use the elimination technique. Okay, we are going to eliminate answers that are totally wrong. And that will be number 1, air has weight. Number 2, air occupies space. Right? Occupying space doesn't mean that it can be compressed downwards. Okay, it can be pushed downwards. So now we are left with air has no definite shape and air has no definite volume. Air has no definite shape. Air has no definite volume. Sounds pretty close, isn't it? All right, sounds pretty close. Actually, I also don't know the answer. So what's the answer? Is it about shape or volume? So typically,
volume.
how do we judge when we talk about space? All right, when we talk about space, every time we talk about space, the concept of space is related to volume. Okay, the concept of space is we talk about volume. So answer number 4. Okay, answer number 4. So in this case, air, we are not talking about the shape, but we are talking about the space.
Volume.
The diagram shows a change of state, liquid to solid, liquid to gas. So let us revisit what we have learned just now. We say water, vapor, condenses into water droplets. Okay, so that's what we learned. We also learned water, vapor, gains heat and evaporates into, not water vapor, water droplets evaporates into water vapor. Okay, and that's why just now we say that the water droplets disappear because cannot see, turns into water droplets, can see. Okay, so water vapor condenses into can see, that must be from gas cannot see to can see. So this must be condensation. From can see to cannot see, this must be evaporation. Okay, so condensation is X. Now then we have solid to become liquid. This is no-brainer, must be melting. All right, solid to liquid is melting. So answer number 4. Okay, exact PSLE questions. So regardless of your ability in science, I think these are things that we can do. Okay, let's take a look at this. Aisha conducted an experiment by heating a substance here. So at 30 degrees, it is a solid. After 15 minutes, it's a liquid. Okay, and after 15 minutes, the temperature goes to 100. Is this an ice cube? Is this substance an ice cube?
No.
Okay, no, because the ice cube cannot be a solid at 30 degrees Celsius. Okay, so what can we tell?
Butter.
The boiling point, because at 100 degrees Celsius, it's already liquid. We know that that cannot be boiling point. All right, so like what Tricia said, this is what I call a hot dog question. Okay, this is what I call a hot dog question. So if the hot dog is at the center, it's a hot dog. Okay, or the burger question. So we say that this is the boiling point. This is the melting point. If the temperature is below the melting point, then here will be solid. If it's in the middle between, it will be liquid. And if the temperature is higher than the boiling point, it will be gas. Okay, so obviously we know that over here, okay, maybe a little bit hard to see. I draw it horizontally. If this is the boiling point, this is the melting or freezing point, then anything on the left hand side here is solid. Anything at the center, which is like the hot dog, is liquid. And anything on the right is gas.
Gas.
Okay, so let's start.
Liquid gas.
The solid is 30 degrees. So we know that over here, the melting point must be at least 30 degrees. So this point here, we can say that it is 30. Over here is 100. So we can make some judgment based on these two numbers. If the temperature is between 30 and 100, then it is liquid. If the temperature is above 100, then it's solid. If the temperature is below 30, then it must be, if it's above 100, it is gas. Below, it must be solid. Okay, so let's start. 105, it will become a gas. So this is wrong. Okay, because at 100, okay, is this correct? No, this is the boiling point. So the boiling point is 105. And then the melting point is 20. So 20 is here. Okay, if it's 20, 20 is here. Which means that if it's 20, then it will be liquid. So it's wrong. Okay. I redraw my question again to make it clearer. So these two are the boiling and melting point, right? So we're going to put in the numbers. Okay, so number one, if the number is 20 and 105, and we say that the cube, okay, this is not an ice cube, solid P, and we say that solid P is a solid at 30 degrees, which is here, it must be wrong. Okay, because anything above 20, it will become a liquid, but over here, 30 degrees is solid, so this is wrong. Okay, if the boiling point is 105 and at 100 degrees Celsius, it is liquid, this is okay. Am I clear enough? Is there anybody who is lost?
No.
Am I okay? Aditya, are you okay? Hayden?
Yeah.
Hayden's okay? Hayden's...
Yes.
Yeah, okay, so we go back again. If the melting point is 25, so we're going to try it many times. 25, and then we put 100 here. So at 25, If P is at 30 degrees, which means 30 is here, it will become a liquid. So P cannot have a melting point of 25. Okay, cannot. But at 100 degrees Celsius, possible. Okay, next, if the melting point is 30 degrees, at 30 degrees, it is a solid. Okay, still possible. Then at 95, put 95 here. 95. Then this liquid P will be here on the right, which means that the liquid P will no longer be a liquid but a gas because liquid P is at 100 degrees Celsius. So this is not possible. Okay, based on elimination, we know that the last answer is correct. Let us test again. This is 50. This is 110. 110. At 110. At 100, it is a liquid. At 30, it is a solid. Okay? So this is true. So answer number 4. Okay, so we're going to do a little bit of elimination kind of thing as we do this question. Okay, when school reopens, I will sieve out a few of this kind of questions for everybody to try again. Right? So the answer is number 4. Those of you who needs to think through and understand this concept again, when I've uploaded the video onto SLS, can you please go to this question again?
Okay.
So my videos will be video MCQ, video open-ended. Okay. Next. Okay, energy I don't want to talk about. Let's go to 6. Which of the following is a possible effect on water cycle when the temperature of the environment changes? So let's see. Condensation of water vapor decreases will result in more rain.
Mr. Chua,
Yes.
but it's quite confusing because I don't know whether the temperature will go higher or lower.
Which question are you talking about?
The question 6. Are they talking about the question the temperature going higher or the temperature going lower?
Okay, let me go through first.
Okay.
Now, when we have more condensation in a water cycle, what does it mean? Where does condensation take place in the water cycle? This is the sun. This is the sea or water. And then this is your mountain. All right. So evaporation takes place here, right? So that's evaporation. Where does condensation take place? Condensation takes place in the clouds. So the clouds is where condensation takes place, and condensation is here. So how can we interpret the question? We can interpret it by saying, if the condensation increases, we're going to have more clouds. If condensation decreases, we're going to have less clouds. Agree? So condensation decrease, you have less clouds, more rain, not possible. Okay, now then we go back to Trisha's question. The temperature of the environment increase means what? Means that it's going to be warmer, means that there's going to be more heat. So more heat in my diagram means what? Higher rate of evaporation, right? So if higher rate of evaporation, will there be higher rate of condensation? So think about it. If it's a sunny day, are you going to have more evaporation? If it's a cloudy, rainy day, are you going to have more evaporation? Okay, so this is a case where the temperature of the environment increase means you're going to have higher rate of evaporation. When the rate of evaporation is higher, then what are we going to expect? We're going to expect more clouds, right? Okay, which also means that condensation will increase. Okay, so let's go back. Condensation of water vapor increases, result in less clouds. You have increased water vapor, how can you have less clouds? You must have more clouds, isn't it? Now the evaporation of water will increase, resulting in more rain. Seems like a plausible answer. Okay, so 3 possible, but let us not jump to conclusion yet. Let us look at option number 4. Evaporation of water decreases, resulting in less water vapor in the air. Will evaporation decrease? No, right? Because higher temperature means higher rate of evaporation, right? Means more clouds form, higher rate of condensation. So with that, the answer is 3. Okay, so evaporation won't decrease, but instead, evaporation should increase. Okay, so we need to read it very carefully. And if you notice, I actually spent quite a while reading and explaining this question.
Yeah.
Okay, so you may want to relook at this question again. Okay, you're going to skip magnets. Temperature, light bulb, that's electricity. Say electricity. Okay, we have some water related. Let's take a look. Water. Sulaiman placed 2 empty identical containers K and M at room temperature. 500 ml of boiling water goes into container K and 250 ml into container M. Notice that they are all boiling water, so the temperature is the same. Both the containers are put in the room, so it's room temperature. So what process is taking place now? What process is taking place now? Is it boiling? No, because I have put the boiled water into the containers already. So now I leave the containers both at room temperature. What process is taking place? There's one process which occurs at all temperatures. So evaporation must be taking place. Okay, so evaporation must be taking place. And when evaporation takes place, there will be heat loss. Okay, evaporation takes place, there will be heat loss. Okay, so we can see from the graphs that the lines are going lower. The lines are going lower. Okay, which one of the following is the correct graph for his result? So which one will drop faster or slower? Pretty obvious, isn't it?
Yeah, container M.
So M with lesser water obviously is going to evaporate a little bit faster. The change of temperature is also going to be faster. So if it's faster, it's going to drop a lot more and reach a lower temperature also faster. Okay, so M must go to a lower temperature faster. So from here, we eliminate the answers. One is definitely wrong because both must start from 100 degrees Celsius. Okay, so one is wrong. So then we go and analyze faster and slower. Now, eventually, both of them are put at room temperature. What does it tell us? So let's go for faster. M will drop faster. So this means that K drops faster. This is wrong. Okay. So now we are left with 2 and 4. In fact, another way of looking at it is that 2 and 4 are both wrong because the final temperature of both containers must be what? Must be the same, right?
Same on room temperature.
Yeah, it must all go to room temperature. So K cannot be higher, M cannot be higher. Okay, K can be faster or slower, but eventually they will all reach the same temperature, which is option number 4. Okay, and in this graph, we can also tell that M is faster, steeper. Steeper means faster. Okay, so M is faster and M is steeper. So answer number 4. Okay, next question. This question is very difficult. Okay, question number 13. You may want to spend some time to try. Okay, since most of us here have learned forces, let's take a look at 15. We'll do a quick one. Anyway, the one in the center look a little bit like Adil when he's very happy. Okay, so jump at the highest point, then land. At which stages did gravitational force act on him? Is it at A, jumping only, highest point only, landing only, or any of the combination? So gravitational force, right? So as I have been saying to those in my class, as long as that particular object or item has weight, gravitational force must be acting on it. Okay, so what are the points? Gravitational force is acting here. Gravitational force is acting here. Gravitational force is still acting on him as he lands. So answer 4. As long as it's on Earth, there will be a gravitational force acting towards the center of the Earth.
看 YouTube 啊？
没有，
没有啊，有没有？
没有，
讲清楚一点，
没有，
再讲多一次。
没有，
没有就好吗？
没有，
有还是没有？有就好啦，有就好啦。
Okay, 19. Looks interesting. I've never seen this question before actually. Carry packed a packet of coffee into a mug without overflowing as shown. Kopi. Which of the following about the packet of coffee is correct? So this question has to do a little bit of matter, right? Matter. Both the shape and volume of the coffee did not change. Did the shape of the coffee change? It does, right? At first it's in a plastic bag. Now it takes up the shape of the mug. Shape of mug. So the shape did change. The shape of coffee changed, but the volume did not. True or false? True lah. If the shape change and the volume changes, then I probably will want to get a big cup everywhere to put the coffee. Then the coffee will have more. The volume of coffee changed, but the shape did not. How can the volume change? Cannot be, right? So here the volume of coffee also changed. Okay, so we only have question 1 and 2, part 1 and 2. The volume didn't change, but the shape obviously changed. So the shape did not change is wrong. We are left with option number 2. Option number 2. Substance R is a liquid at 160 degrees. and a gas at 480 degrees. Which of the following is possible? Now, this is the exact same question as question number, is it 6? 4, question number 4. Okay, so what do? We go to the melting point and we draw a graph that looks like this, 120, 450. Okay, then now we look at this. At 160 degrees, which is here, it is a liquid. Correct. At 480, it is a gas. Correct also. Okay, so number 1, possible. Okay, but is that the correct answer? We don't know. Okay, most probably, but we want to check the rest of the options also. So let's look at option number 2, 120, 500. At 160 degrees, here it is liquid. Correct. At 480, it is here. And what does it mean? If 480 is here, it means that the state of the substance must be liquid. But here it says it's a gas. So this is wrong. Okay, let's look at option 3, 200, 450. At 160, it is here. And on the left is solid. So this is wrong. We no need to look at others. Okay, last question, 200 and 500. At 160, it is solid. So this is also wrong. And with that, we conclude that option number 1 is the answer. Okay, so question 20, I would like all of you, especially those of you who are not so strong in math, to re-look at question number 4 and question number 20. Okay, these 2 questions, you realize that in 3 years of PSLE, it has appeared 2 times. Okay, so in 3 years, it has appeared 2 times. Okay, next question. Circuit. Fireman. North-South pole. Light and shadow. Here, exposed surface area. Okay, so exposed surface area. Okay, let me give you maybe 30 seconds to 1 minute to read the question first. So Ahmad conducted an experiment by placing 2 glass beakers, each containing 50 ml of liquid in the same temperature. The liquids were kept at different temperatures. He measured the volume of liquid L remaining in each beaker after some time. Part of his results are as shown. So exposed surface area, meaning the opening of the beaker, is the same. Volume at 1, more left, less water left. And then temperature is at 60. So at this point in time, can you tell me if beaker 1 or beaker 2 has a higher rate of evaporation? Which one has a higher rate of evaporation? Cassandra, why not you share? Which one has a higher rate of evaporation? The one with more volume or the one with less volume?
More.
More volume is higher rate of evaporation.
Yeah.
Remaining,
Or less.
please read carefully. Hello. Okay, so remaining 40 means this must be lower rate of evaporation. Okay, so in the learning of science and answering of science question, we must read very carefully such words. Okay, remaining. Okay, so this is higher rate of evaporation. So what can we tell if the rate of evaporation is lower? What can we tell of this temperature T? What can we tell of this temperature T? Maybe we hear from Abro. Why not you share with us? What can we tell of this temperature T? Bigger or smaller?
Bigger.
Bigger, but it has a lower rate of evaporation.
I think bigger has more exposed surface area.
No, the exposed surface area is the same.
Oh.
So with 40 ml of liquid remaining, it has a lower rate of evaporation. Now, how do we visualize such a question? We think about it this way. Today I play sports for, let's say, half an hour and I'm sweating. Do I want the weather to be warmer or do I want the weather to be colder?
Colder.
If I want it to be colder,
Colder.
I will have lesser rate of evaporation or higher rate of evaporation.
Higher rate.
Okay, if I want higher rate
Lesser.
evaporation, I want the temperature to quickly evaporate the water, right? Okay, I'm not talking about wind, I'm talking about temperature only. Okay, so with a lower rate of evaporation, it must mean that T must be smaller. Are you okay? Hey, bro, T must be smaller. All right. Now, he then repeated the experiment using another 2 beakers. Now, he keeps the temperature the same. And he uses 128, another one don't know. And the volume of the L remaining is 30 and 20. So let's go back to the same question again. Which has a higher rate of evaporation? Why not we hear from Roshan? Let's try Roshan. Which one will have higher rate? 3 or 4?
4.
4, because 20 remaining. So it means less remaining, so this must be higher. Okay, thank you. And this must be lower. Now, if this is lower rate of evaporation and the exposed surface area is 28, higher rate of evaporation, what will be the exposed surface area? Let's hear from some people from my class. Let's hear from either Fasliana or Pierre or Rehan or Shamil. You'll just turn on your speaker and talk. Higher rate of evaporation, exposed surface area, is it going to be bigger or smaller? Pierre.
Smaller.
Smaller. A smaller exposed surface area will give you higher rate of evaporation.
Higher.
Higher or smaller?
Higher.
You said both answers, so which is your final answer?
Higher.
Higher, thank you. Okay, so higher rate of evaporation, exposed surface area must be bigger than 28. Okay, so from here, we can start our elimination. T must be smaller than 60. And T must be higher than 28. And only option 2 is correct. Okay. Now, so this is a pretty demanding question for those of you who don't read very, very carefully. Okay. I think the MCQ seems a little bit more difficult than the open-ended. Okay, I strongly suggest that you look through the video again once I've uploaded it. Okay, maybe let's look at 29 a little. I have a roll of measuring tape. Why is the measuring tape suitable for measuring curved lengths along human bodies? Because it is strong, because it's flexible, because it's waterproof, or because it is an electrical conductor. Okay, quite easy, right? You want it to measure curves. It must be flexible. Okay, so 29 is 2. Okay, let's look at 35. Let's look at 35. Okay, looks quite like the question we see earlier. Using a pump, 5 centimeter cube of water and 10 centimeter cube of air are added. So you add 5 more centimeter cube of water to the 15 already inside. So the amount of water is now equals to 20 centimeter cube. What will be the final amount of air in the container? So we say that we add in 10 more. So 35 plus 10 equals to 45. And we have a 45 here. The question is this the correct answer? Okay. Earlier in the question, I think Trisha mentioned one important thing. She said air can be compressed. So what should the answer be? Okay. Now, always remember the total, and this is something you probably want to write down. Huh? The total volume remains the same. Or rather, the total volume of container remains the same. Okay? But when we add water inside, if water already occupies 20 centimeter cube, the total remains the same. And what is the total? What is the total here? 35 plus 15, right? Which is 50. So if the total is 50, the total remains the same, and water has increased by 5 cubic centimeter to 20, then 50 minus 20 gives us 30, and the amount of remaining must be 30. Okay? So air can be compressed. The volume of the air will always take up the shape of the remaining container. So answer number 2. Okay, and not number 4. Electricity, waterproof. Okay, let's not do 37. Water, electricity, magnets, spring. Have you all seen this question before?
Yes.
When did you all see this question?
Like performance like that.
Last year.
Last year.
Year.
The CA1 paper, isn't it?
In the paper you gave us.
Last year, end of the year question. So I copied from PSLE question. This was a PSLE question, 2019. So after looking at the paper, I copied. Okay. Okay, so if not, then we are done for today with all the water-related question as well as question relating to matter. Okay, so next lesson on science, we will be going into life science. Okay, we'll go into life science. Okay, now before we end today,
What do you mean?
okay, so basically, if you take a look at your PSLE booklet, you will notice that science is divided into two parts. One is called the physical science. The other one is called life science.
Life science.
Life sciences involves animals, plants, things related to life, human life. Physical sciences refers to topics like energy, magnets, matter, a lot to
Non-living things.
a bit of non-living things in our everyday life. Okay, so you can see it as life science is living things, and for physical science is non-living things. Okay, that's one possible way of looking at it. Okay, before you go, I have a web link that I would need you to go into. Right, so I'm going to write it here. It's actually a Padlet. So if you have access to the class website already, okay, if you have access to our class web, okay, the link is there. You can click on the link to key in. If not, then this will be the link. Maybe let me go to this.
Mr. Chua,
Yes.
sorry, I need to go already.
Now, whoever needs to leave, you can fill in the feedback later. Okay, so those of you who are done, you can take a look at this feedback and then you key in this feedback accordingly. Right? Else, I'm done for today. And thank you for being around. Hope you have learned something.